Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving systems of equations by substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem, y equals 6x minus 11, and minus 2x minus 3y equals negative 7, and we need to solve this system by substitution. Well, what I do first is I look at my two equations. First one, I already have a variable by itself. That helps us here. So I take the second equation, minus 2x minus 3, and then instead of y, I'm going to plug in this value in for that y, because y equals 6x minus 11. 6x minus 11 here, okay? Then we finish out the second equation, minus 7. So now I need to solve for x. Minus 2x here. Distribute the minus 3, and we have a minus 18x. And then minus 3 times the negative 11 is a positive 33. And that equals a negative 7. From there, we want to combine our like terms. Negative 2x and negative 18x is a negative 20x. We're subtracting a 33 to both sides. And we're left with negative 7 minus 33, which is a minus 40. We then divide both sides by minus 20, and we're left with x by itself. Negative 40 divided by negative 20 is a positive 2. So now we have one of our values. We have to find the y value. We take this 2 and we plug it into a second equation. Or into either one of the equations. Pick an easier one. First equation, I think it's easy. 6 times 2, 2 in for x, minus 11. Y equals 6 times 2 is 12, minus 11, and 12 minus 11 is 1. So we have y is 1, x is 2, and so my final answer is 2, comma 1. Okay? Alright, we're given this problem here. 2x minus 3y equals negative 1, and y equals x minus 1. Well, when I'm dealing with substitution, I can see, or try to get a variable by itself. We already have that here. Y equals x minus 1. So what do I have to do? I take the first equation, 2x minus 3, and then instead of that y, I'm putting this value in. Your x minus 1 here. And then we're equal to negative 1. Now we have to solve for x. 2x comes down. Distribute the minus 3 to both parts. Minus 3 times x is minus 3x. Minus 3 times minus 1 is a positive 3. Equals a negative 1. Now we want to keep simplifying, so let's bring our like terms together. Subtract 3 to both sides. Minus 1 minus 3 is a minus 4. And 2x minus 3x is a minus 1x. From there, divide both sides by negative 1. And x equals, well, negative 4 divided by negative 1 is a positive 4. We take that information and we want to plug that into one of our original equations. Find the easier one, second equation. So y equals 4 minus 1, and 4 minus 1 is 3. So our coordinate point is 4, comma 3, and that is our final answer. We're given this problem here. Y equals minus 3x plus 5, and 5x minus 4y equals negative 3. And we have to solve this by substitution. If we take the second equation, 5x minus 4, but instead of the y, we're going to substitute the first equation, the y value here, being minus 3x plus 5. Then we continue the second equation, equals minus 3. From there, we want to simplify this and get x by itself. So 5x comes down, distribute the minus 4. Minus 4 times minus 3x is a positive 12x. Minus 4 times a positive 5 is a minus 20. And we have negative 3 left over there. Okay. So now we want to simplify as much as we can. We add a 20 to both sides. And 5x plus 12x is a 17x. Oh, simplify this. Minus 3 plus 20, continue that step, is 17. Divide both sides by 17. And we're left with x by itself, and 17 divided by 17 is 1. So where do we go from here? All right. Well, we need to take that x equals 1, and we're plug it back into one of our other equations and solve for y. First equation looks easier. Y equals a minus 3 times 1 plus 5. From there, we need to simplify. So y equals minus 3 times 1 is minus 3 plus 5. And, well, minus 3 plus 5 is a positive 2. So our coordinate point here is 1, 2, and that is our final answer. We're given this problem here. Minus 3x minus 3y equals 3. And y equals minus 5x minus 17. We want to solve this system by substitution. Well, we can see the second equation already has y by itself. So we're going to use that to our advantage. We take the first equation, minus 3x minus 3 and then y, but instead of y, we're going to plug in this part here, minus 5x minus 17 from the second equation. We continue the first equation, that equals 3. So from here now we're going to simplify and solve for x. We have minus 3x here, and then distribute the minus 3. Minus 3 times the minus 5x is a positive 15x. Distribute again, and minus 3 times a minus 17 is a positive 51. And that equals 3. From there, we still want to simplify. We subtract 51 to both sides. Okay. And negative 3x plus 15x here is 12x. And that equals 3 minus 51 is a minus 48. This marker is dying. I'll switch in a second. Divide both sides by 12. And we have x completely by itself. And that equals a minus 4. Alright, let's get a new marker for the next part here. Let's go in blue. It works. So we have x equals negative 4, and we're going to take that information and we're going to plug it into the second equation because it looks easier. We can pick either one, but let's choose the second. So we have y equals, that's much better, minus 5 times x, minus 4 here, minus 17. Okay. Well, y equals minus 5 times minus 4 is a positive 20, minus 17. 20 minus 17 is 3. So now we have our x and y value. We can write that as a coordinate point, minus 4, 3, and there is our final answer, minus 4, 3. We're given this problem, y equals minus 2, and 4x minus 3y equals 18. And we want to solve this by substitution. Well, y equals negative 2 is already by itself. That helps us. So we take the second equation, 4x minus 3, and instead of y, we put a minus 2 in there. And then continue the equation, equals 18. So now we're solving for x. 4x minus, well, minus 3 times minus 2 is a positive 6, equals 18. Subtract 6 to both sides, and 4x equals 18 minus 6, which comes out to be 12. Divide both sides by 4, and x equals 12 divided by 4, which is 3. So normally now I would take that value and plug it into one of my equations to solve for y. But we're already given y in the first equation. It's negative 2. So we have our answer now. X is 3, y is negative 2, and that is our final answer. We're given this problem here, y equals 5x minus 7, and negative 3x minus 2y equals negative 12. And we want to solve this system by substitution. Our first equation is already having the y variable by itself. That helps us. We take the second equation then, minus 3x minus 2y, but instead of y, we plug in this part of the first equation, 5x minus 7. And that equals negative 12. Now we have to solve for x. Minus 3x comes down. We distribute the minus 2. Minus 2 times 5x is a minus 10x. Minus 2 times the minus 7 is a positive 14. Negative 12 just comes down. Subtract 14 to both sides. And we're left with, on the right-hand side, minus 12 minus 14 is a minus 26. Left-hand side, negative 3x minus 10x is a minus 13x. Divide both sides by minus 13. and x equals negative 26 divided by negative 13, which is a positive 2. So we have our x value, we want to find our y. We take this x equals 2 and plug it in to one of our first two equations. The first one I think is easier. Y equals 5 times that 2 minus 7. From there, y equals 5 times 2 is 10 minus 7, and 10 minus 7 is 3. So our answer here is 2, 3, and that is our final answer. We're given this problem here, minus 4x plus y equals 6, minus 5x minus y equals 21, and we want to solve this system by substitution. Well, first thing here is, well, none of our equations have a variable by itself, but the first one I can easily get y by itself. To do that, I add 4x to both sides. So that gives us here y equals, adding a 4x, positive 4x plus 6. With that information, I take the second equation, minus 5x minus, and I'm substituting this y in for the second equation, which is 4x plus 6. Hence the term substitution. And that equals 21. From there, we want to, again, solve for x, get x by itself. So simplify minus 5x, distribute the minus sign, minus 4x, minus 6 equals 21. We add 6 to both sides here. On the right-hand side, 21 plus 6 is 27. Negative 5x minus 4x is a minus 9x. From here now, we want to get x again by itself. Divide both sides by 9, or negative 9. And x equals 27 divided by negative 9, which is a negative 3. So we have x equals negative 3 here. Well, we want to take that value and plug it into one of our other equations and solve for y. I think the first equation is easier. We take negative 4 times negative 3 plus y equals 6. Negative 4 times negative 3 is a positive 12 plus y equals 6. Subtract 12 to both sides, and y equals 6 minus 12, which is a negative 6. So our answer here is negative 3 comma negative 6, and that is our final answer. We're given this problem here, minus 7x minus 2y equals negative 13, and x minus 2y equals 11. And we want to solve this system by substitution. The second equation, I can see I can get the variable x by itself fairly easily. By adding 2y to both sides, I'm left with x equals positive 2y plus 11. We then can take that information and plug it into the x value in the first equation. Minus 7. Now instead of x, we plug in 2y plus 11, and we finish the first equation. Minus 2y equals negative 13. Hence that substitution right there. We distribute the minus 7 to both parts. Minus 7 times 2y is a minus 14y. Minus 7 times 11 is a minus 77. And a minus 2y here, and then negative 13. Well, we can add a 77 to both sides. And we're left with, on the right-hand side, minus 13 plus 77, which is a positive 64. Combine the minus 14y and minus 2y, and we have a minus 16y. Divide both sides by a negative 16. And y by itself is 64 divided by negative 16 is a negative 4. We then have to take that information and plug it into one of our first two equations to solve for x. I think the second equation is easier. X minus 2, negative 4 in for y, equals 11. Well, x minus 2 times the minus 4 is a positive 8, equals 11 here. And then subtract 8 to both sides. And x equals 11 minus 8, which is 3. So our coordinate point here is 3 comma negative 4, and that is our final answer. We're given this problem, minus 5x plus y equals a negative 2. Negative 3x plus 6y equals a negative 12. And we want to solve this system by substitution. We want to get one of these equations variable by itself. The first equation looks the easiest. If I just add a 5x to both sides, y is by itself. So y equals, adding a 5x to both sides, positive 5x minus 2. We then can take this value and plug it into the y in our second equation. So minus 3x here plus 6 times 5x minus 2, and for that y equals a negative 12. Now from here we're solving for x. Minus 3x comes down, distribute the 6, plus 6 times 5, 6 times 5 is 30x, or 30x right here, right? And 6 times the minus 2, we have a minus 12, equals a negative 12. So let's combine our like terms. We add 12 to both sides. Negative 12 plus 12 is 0. Negative 3x plus 30x is a positive 27x. From there, we divide both sides by 27, and x equals 0 divided by 27 is just 0. We take that information and we need to plug it into one of our first two equations to solve for y. Pick the easier one. I think it's the first one. Minus 5, and instead of x, we put 0. Plus y equals a minus 2. Negative 5 times 0 is 0, plus y equals minus 2. Don't really need to write 0 plus y, so we just write y equals a minus 2. And we can write these 2 points now, or 2 parts, as a coordinate point. 0 for x, y is negative 2, and our coordinate point is 0, comma, negative 2. We're given this problem, minus 5x plus y equals a negative 3. 3x minus 8y equals 24, and we need to solve this by substitution. Our first equation, I see I can get y easily by itself, so that's my first step. I add 5x to both sides, and I'm left with y equals a positive 5x minus 3. With that information, I'm going to take this 5x minus 3 and plug it into y in the second equation. 3x minus 8 times 5x minus 3 equals 24. From there, I want to get x by itself. We simplify. 3x comes down, distribute the minus 8 to both parts. Minus 8 times 5x is a minus 40x. Minus 8 times a minus 3 is a positive 24, and that equals 24 here. From there, we subtract 24 to both sides, and we're left with 24 minus 24, which is 0. 3x minus 40 is a negative 37x, or 40x. Divide both sides by a negative 37, and x equals 0 divided by negative 37, which is 0. From there, we want to solve for y. We take this x value equals 0 and plug it into one of our first two equations. Pick the easier one. I think it's the first one. Minus 5 times 0, and for x, plus y equals a minus 3. From there, negative 5 times 0 is just 0, plus y equals a minus 3. Well, we don't really need 0, so y equals a minus 3, and there we have it. As a coordinate point, we have 0, comma, negative 3, and that is our final answer. We're given this problem here, x plus 3y equals 1, and minus 3x minus 3y equals a negative 15. And we want to solve the system of equations by substitution. My first equation, I can see I can easily get x by itself. Subtract the 3y to both sides. So to do that, I have x equals, we'll subtract 3y, so minus 3y on the other side, plus 1. We take that information, and we're going to plug that in for our x value in the second equation. Minus 3 times the x value, minus 3y plus 1, minus 3y equals a negative 15. From here, we want to solve for y. Distribute the minus 3 to both parts. Minus 3 times a minus 3y is a positive 9y. Minus 3 times 1 is a minus 3. We subtract 3y again, and equals negative 15. Well, now we want to combine our like terms. So we add a 3 to both sides. Negative 15 plus 3 is a negative 12. 9y minus 3y is 6y. From there, I want to divide 6 to both sides. And we're left with y by itself equals negative 12 divided by 6 is a minus 2. From here, we want to take that information and plug it into one of our first two equations and solve for x. I think the first one's easier. So x plus 3, and instead of y, and put a minus 2 in, equals 1. From there, I'm solving for x. X plus, well, 3 times a negative 2 is a minus 6, equals 1. Add 6 to both sides, and we're left with x equals a positive 7. So writing this as a coordinate point, it's 7 comma negative 2, and that is our final answer. We're given this problem, minus 3x minus 8y equals 20, minus 5x plus y equals 19, and we want to solve the system by substitution. Our second equation catches my eye. I can see I can easily get y by itself here. All I have to do is add a 5x to both sides. So to do that, we have y equals, add a 5x plus 19. Not too bad. We take that information and we're going to plug 5x plus 19 into y of our first equation. Minus 3x minus 8 times y, which is 5x plus 19, equals 20. So then from here, we want to solve for x. Minus 3x here, minus 8 times, negative 8 times 5x is minus 40x. Make sure we distribute to both parts. And negative 8 times 19 is a negative 152, and that equals 20. From there, we're solving for x. We add 152 to both sides, and that leaves us with 20 plus 152 is 172. Negative 3x minus 40x is a minus 43x. Divide both sides by a minus 43. And we're left with x by itself equals 172 divided by negative 43 is a negative 4. So with that information, we want to plug that into one of our first two equations and solve for y. The second equation looks easier. We have a minus 5 instead of x. I'm putting a negative 4 in, plus y equals 19. Solving for y. Negative 5 times a minus 4 is a positive 20, plus y equals 19. Subtract 20 to both sides, and y equals 19 minus 20, which is a minus 1. So our coordinate point value is minus 4 comma minus 1, and that is our final answer. We're given this problem here, minus 3x plus 3y equals 4, minus x plus y equals 3, and we want to solve the system by substitution. My first goal is to see if I can get a variable by itself in one of the equations fairly easily. The second equation looks simple. All I have to do is add an x to both sides and y is by itself. So if I did that, y equals, add an x to both sides, x plus 3. Not too bad. So we take that information and we're going to plug it into y in the first equation. Minus 3x plus 3 times y, which is x plus 3 here, equals 4. From there, we're solving for x. Minus 3x here, plus 3 times x is 3x, plus 3 times 3 is 9. Make sure we distribute to both parts here, and that equals 4. All right. Minus 3x plus 3x is just 0x. They cancel each other out, and we're left with 9 equals 4. Well, is that a true statement? Does 9 equal 4? Well, no. They're not equal. It's not true. So what does that mean here? That means we have no solution. There is no solution for this system of equations, and that is our final answer. We're given this problem, minus 3x plus 3y equals 3, and minus 5x plus y equals 13. And we want to solve the system by substitution. I can see in my second equation, I can get y by itself very easily. I have to add a 5x to both sides. So to do that, I can write y equals, add 5x to both sides, positive 5x plus 13. Well, how does that help us here? Well, we can take that y value, being 5x plus 13, and substitute it in for y in the first equation. So we have minus 3x here, plus 3 times y, which is 5x plus 13, and that equals 3. So where do we go from here? we got to solve for x. Minus 3x comes down, plus distribute the 3 to both parts. 3 times 5x is 15x. 3 times 13 is a 39, and that equals 3. We subtract 39 to both sides. Let's get our like terms together. And 3 minus 39 is a minus 36. Negative 3x plus 15x is a positive 12x. Divide both sides by 12 here, and we get our goal of x by itself to be negative 36 divided by 12, which is a negative 3. We take that information and we need to plug it into one of our first two equations to solve for y. I picked the second equation because it's easier. So minus 5, or I think it's easier. Negative 3, and for x there, plus y equals 13. Now again, we're solving for y. Negative 5 times negative 3 is a positive 15, plus y equals 13. Subtract a 15 to both sides. Y is by itself, and 13 minus 15 is a minus 2. So we have our x value of negative 3, y value of negative 2, and that is our final answer. We're given this system, 6x plus 6y equals negative 6. 5x plus y equals negative 13, and we need to solve this system by substitution. I want to get a variable by itself, and I see the second equation is the easiest way to do that. All I have to do is subtract a 5x to both sides, and y is completely by itself. So we do that and subtract a 5x, and we get y equals a negative 5x minus 13. With that, we're going to substitute negative 5x minus 13 in for this y. 6x plus 6 times y, y being minus 5x minus 13, and that equals minus 6. So now we want to solve for x. 6x comes down. Distribute the 6 over. 6 times a negative 5x is a minus 30x. 6 times a minus 13 is a minus 78. And that equals a minus 6. From there, we want to combine our like terms. We add a 78 to both sides here. And negative 6 plus 78 is a 72. Here, 6x plus a negative 30x is a minus 24x. Divide both sides by a minus 24 to get x by itself, and x equals 72 divided by a negative 24 is a minus 3. So we have our x value, we need to find our y value. We take that information here, and we plug it into one of our first two equations to solve for y. The second equation looks easier, so I'm going to choose that. 5 times negative 3 instead of x plus y equals a negative 13. 5 times negative 3 is a negative 15 plus y equals negative 13. Add a 15 to both sides. Y is by itself, and negative 13 plus 15 is a positive 2. So we get the coordinate point here, negative 3 comma positive 2, and that is our final answer. We're given this problem, 2x plus y equals 20, and 6x minus 5y equals 12. And we want to solve the system by substitution. Well, I look at the first equation, and I can see I can get the variable y by itself fairly easily. I subtracted 2x to both sides, and y is by itself. So we do that. Y equals, we subtract 2x to both sides, minus 2x plus 20. Not too bad. We take that information, and we're going to plug the negative 2x plus 20 in for the y value in our second equation. 6x minus 5 times the y value minus 2x plus 20 equals 12. So connect these two here. Well, now we want to solve for x. 6x comes down. Distribute the minus 5. Minus 5 times the minus 2x. Minus 5 times minus 2x, oof, that's a positive 10x, lost my place there. And negative 5 times 20 is a minus 100. And that's equal to 12. We add 100 to both sides. And that gives us on the right hand side, 12 plus 100, 112. 6x plus 10x comes out to be a 16x here. Divide both sides by 16. And x equals 112 divided by 16, which is 7. So we take that information and we need to plug that into one of our first two equations to solve for y. Pick the easier one of the two. I think it's the first one. 2 times 7, so 7 for x, plus y equals 20. 2 times 7 is 14, plus y equals 20. Subtract 14 to both sides, and y equals 20 minus 14, and that is 6. And so we're given the coordinate point now, 7, 6, and that is our final answer. We're given this problem here, minus 3x minus 4y equals 2, and 3x plus 3y equals a negative 3. And we want to solve this system by substitution. Well, my goal is to try to get a variable by itself. And nothing really jumps out right away. But the second equation has 3 going in all parts. So I think it'll be easy to get a variable by itself. So what I'm going to do is I'm going to try to get x by itself here. So I'm going to subtract a 3y to both sides. That gives us here 3x equals a negative 3y minus 3. So subtract a 3y to both sides. I then can divide both sides by 3, and now x is by itself. Negative 3 divided by 3 is a negative 1, so we have a negative y here, and negative 3 divided by negative 3 is a negative 1 there. Alright, so where do we go from here? Well, we take that information, and we're going to plug that x value, negative y minus 1, into the x value of our other equation, the first one. So negative 3 times, instead of x here, I'm putting a minus y minus 1. Then we subtract 4y, and that equals 2. So at this point, we're solving for y. Distribute the minus 3 to both parts. Minus 3 times y is a positive 3y. Minus 3 times a minus 1 is a positive 3. And then minus 4y here equals 2. From there, we subtract a 3 to both sides. Let's get our like terms together. 2 minus 3 here is a negative 1. And 3y minus 4y is a negative y, or negative 1y. Divide both sides by negative 1, and y equals negative 1 divided by negative 1, which is a positive 1. Alright, with that information, we have to plug it back into one of the first two equations to solve for x. Try to pick the easier one. Both are about the same. I'm just going to pick the second one here. So 3x here, plus 3 instead of y, I'm putting a positive 1, equals a negative 3. 3x plus 3 times 1 is 3, equals negative 3. Subtract 3 to both sides. 3x is by itself here, and negative 3 minus 3 is a negative 6. Divide both sides by 3, and x equals a minus 2. So x is minus 2, or negative 2, y is a positive 1, and that is our final answer. We're given these two equations, negative 2x plus 6y equals 6, and negative 7x plus 8y equals a negative 5. And we want to solve this system by substitution. Well, to do that, I need to get a variable by itself. So I'm looking at these two equations, and I want to pick my first one here to try to get the variable x by itself. So that first equation, I have negative 2x plus 6y equals 6. Subtract the 6y to both sides, and I have a minus 2x equals a negative 6y plus 6. Now I can divide both sides by negative 2. And we're left with x by itself equals, well, negative 6y divided by negative 2 is a positive 3y. 6 divided by negative 2 is a minus 3. So we have x by itself, well, equal to 3y minus 3. And we need to plug that value into our second equation's x value. So negative 7 here, but instead of x, I'm putting in 3y minus 3. Then plus 8y equals a negative 5. And now we need to solve for y. To do that, I'm distributing the minus 7 to both parts. Negative 7 times 3y is a minus 21y. Negative 7 times a negative 3 is a positive 21. We have an 8y here and a negative 5. Well, let's bring our like terms together. Subtract 21 to both sides. Negative 5 minus 21 is a negative 26. Combining the y values, negative 21y plus 8y is a negative 13y. Divide both sides by a negative 13, and y equals a negative 26 divided by a negative 13, and that is a positive 2. So we take that information and we need to plug it into one of our first two equations to solve for x. I think the first one's easier. So we take negative 2x plus 6, and instead of y, I'm putting that 2 in for it. And that equals 6. Simplify. Oh, not a 3, that's a 2 there, Sean. So we have minus 2x here, plus 6 times 2 is 12, equals 6. Subtract a 12 to both sides. And 6 minus 12 is a negative 6, and then negative 2x comes down. Divide both sides by negative 2, and x equals negative 6 divided by negative 2, positive 3. So our value for x is 3, y value is 2, and we're given the coordinate point now, 3, 2, and that is our final answer. We're given this problem here, minus 5x minus 8y equals 17, and 2x minus 7y equals a negative 17. And we want to solve the system by substitution. Well, I want to get a variable by itself. And the easiest one I think, or easiest way to do it, I think is with the second equation. And I think I can get x by itself fairly easily. So you take this, and to do that I have to add a 7y to both sides. So that gives us 2x here equals positive 7y minus 17. Well then from there, to get x by itself, divide both sides by 2. X is now by itself, but 7y, or 7 divided by 2 is 3.5, so we have 3.5y here, minus 17 divided by 2 is 8.5. So now from there, we're going to take that information, that value for x, and plug it into x in our first equation. So we have a negative 5 here, and instead of x, I'm plugging in 3.5y minus 8.5, and that, not equals. Finish the equation out there, Sean. Minus 8y equals 17. So again, we're solving for y. Distribute 5 to both parts, or negative 5. Negative 5 times 3.5 is a negative 17.5. Keep the y. Negative 5 times a negative 8.5 is a positive 42.5. Minus 8y equals 17. I'm going to subtract a 42.5 to both sides. Let's get our like terms together. And we're left with, on the right hand side, 17 minus 42.5, which is a negative 25.5. Negative 17.5 y minus 8.5y is a positive 25.5 y. Divide both sides by 25.5. And y by itself is equal to, well, negative 25.5 divided by 25.5 is a negative, or sorry, it's a, whoopsie, that's a negative, right? That's a negative 25.5, excuse me. Good thing I caught it there. If you had caught it already, let me know down below. That's two negatives make it a positive. So we have positive 1 here for y. Almost messed that up. Good thing I caught it though. Alright, so I have y by itself here. I need to plug it into one of my other equations to solve for x. I think the second equation is easier. Maybe it's just because I like working with the number 2. 2x minus 7 times 1 equals a negative 17. 2x here minus, well, 7 times 1 is 7 equals 17. Add 7 to both sides. And 2x here equals 17 plus a 7. Oh my goodness, this is minus 17. I keep messing up my negatives. Woof! Negative 17 plus 7. Oof, this video's been bad, sorry. Negative 17 plus 7 is a negative 10. But I caught them all, so give me props to that at least. Divide both sides by 2, and x equals negative 10 divided by 2 is a negative 5. And so our coordinate point is negative 5, 1, and with all my almost mess ups with negatives, but I caught them all, our final answer is negative 5, 1. We're given this problem. Negative 2x minus y equals negative 9. 5x minus 2y equals 18. And we want to solve this system by substitution. Our first step here is to get one of the variables by itself. I think the easiest one is in the first equation to get y by itself. So to do that, if I add 2x to both sides, I'm left with a minus y equals a positive 2x minus 9. But I just want y by itself. So I'm going to divide both sides by a negative 1. And that gives me y equals a negative 2x plus 9. Okay? All right. So with that information, we're going to take that y value, being negative 2x plus 9, and plug it into the y value of our second equation. Hence, substitution. 5x here minus 2 times y minus 2x plus 9 equals 18. All right? So now we want to get x by itself, solve for x. 5x comes down. Distribute the minus 2 to both parts. Minus 2 times minus 2x is a positive 4x. Minus 2 times 9 is a negative 18. And that is equal to 18 here. Okay? Well, let's add 18 to both sides. Let's get our like terms together. 18 plus 18 is a 36. 5x plus 4x is 9x. Divide both sides by 9. And x is equal to 36 divided by 9, which is 4. Halfway there. We got to get to the solve for y at least. So try to find an equation which I think is easier to solve for y. Again, I think it's the first equation. Minus 2 instead of x, I put in that 4. Minus y equals a negative 9. Negative 2 times 4 is a negative 8. Minus y equals a negative 9. Add 8 to both sides. Negative y equals negative 9 plus 8 is a negative 1. Divide both sides by negative 1 to keep y positive, and y equals, well, negative 1 divided by negative 1 is a positive 1. Our x value is 4, our y value is 1, and our final answer is the coordinate point 4, 1. If you found this video helpful, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.